differentiate y is equal to x squared from first principles. So to do that, that is given by dy dx, that is the derivative of y with respect to x, is given by the limit as the small change in x tend to 0 of change in y over change in x. So what this means is that if you have a curve, let's say you have a curve that looks like that. You have y and you have x, and then on the curve you have 2 points, A and point B. So there are 2 ways you can get the gradient of this curve. One, you can just get the gradient between A and B by just drawing a chord called AB. In another case, the spontaneous one, or in instantaneous, you can just draw a tangent at that point. But you realize that if you move A towards B, the change in x reduces, or it diminishes. So eventually it will become 0, because at one point, let's say you move A up to somewhere here, so that you have A1, up to somewhere there, so that you have A2. If you join A1 to B, or join A2 to B, if you continue doing that, eventually AB, the chord AB, will be the same as the tangent at B. So it means that that small change in x will diminish, so it is tending to 0. So that is what we mean here. So what we're going to do is we're going to pick these 2 points. The first point you're going to pick is A, which is x, and y is x squared. And then you're going to pick point B. So point B, if you move towards B, it means there's some change in x. So it means x at point B will be that x plus some small change. And then y is just x squared. So this is the x that we have. So x squared will be that x squared. So from there, we're going to get change in y over change in x. That is like the gradient. So how do we get the gradient? We just take the change in y. In this case, just take this particular y, which is x, plus small change in x squared, minus the initial point there, which is x squared, over x plus small change in x minus x. So we can expand this using the quadratic identities. That will be x squared plus 2x small change in x plus small change in x squared. So that minus x squared over, this will be small change in x, because x minus x is 0, so it will be change in x. So we can simplify that so that we have x squared minus x squared, that is 0. So we are left with 2x change in x plus change in x squared over change in x. So there is a common factor in the numerator, that is change in x. So you can factor it out so that you have change in x into 2x plus change in x over change in x. So that one will cancel with that, so that you are left with 2x plus change in x as our change in y over change in x, or as our gradient function. So you can use this to obtain dy dx, or the derivative of that particular curve y is equal to x squared. So you will say that dy dx is given by the limit as that small change in x tends to 0 of the gradient. So that is the same as the limit as change in x tends to 0. Our gradient is this one here, 2x plus small change in x. So we have 2x plus small change in x. So what this means is that any term within this expression that has got the small change in x will become 0. So this is the only part that will be 0. So we will be left with 2x. So it means our from first principles, the y, the x is equal to 2x. For that curve, y is equal to x squared.